Welcome to Climate Curious Quickies, bite-sized nuggets of climate goodness from our TEDx experts in under 10 minutes.
In this week's Climate Curious, we're speaking to a conservation chemist to ask how he's helping to protect nature's most endangered species through chemistry. After noticing 6 sea turtles on the beach, Tim couldn't help but think, isn't this avoidable? Leaving his job in pharmaceuticals to join the rare ranks of conservation chemists, Tim went about putting his scientific skills to work, already helping to save fungus-infected frogs and diseased elephant seal pups from their demise. On why chemistry is the new frontier of conservation, here's Tim Cernak. Stay curious.
My name is Tim Cernak. I'm a professor of medicinal chemistry at the University of Michigan, and I'm launching an area of research we call conservation chemistry. We hope that we can make medicine to prevent the extinction of endangered species. So I spent a career in the pharmaceutical industry before coming into this role, and I saw the power of chemistry to improve health. Thinking about diseases like cancer or COVID or diabetes, I mean, we've gotten really good recently in making medicines for such afflictions in humans. And when I looked at ecosystem health, I was shocked by how urgent I think the need is to improve ecosystem health. Now, you talked about climate change, and that's, I think, an obvious one that we'll look at is the big problem affecting our planet right now. But it's really just one of several challenges that ecosystems are facing right now. We're also dealing with invasive species. We're dealing with diseases that are really threatening endangered populations of plants and animals. And so, looking at the pharmaceutical industry as a an area where we've done so much to accelerate the invention of medicines, we wondered if we could look at health challenges in the environment through that lens. So as a kid, I spent my time running through forests, chasing frogs and turtles, and I've just always been really passionate about nature. This was something that was super exciting to me. When COVID emerged, I was really quite scared that, like, what if that was an extinction event for humanity? And I think as a chemist, it was obvious to jump into that situation, right? My lab pivoted hard into COVID medicine, and as did so many of my colleagues and friends. And I think that once it became clear that we were going to get out of COVID okay, then we started looking around at other large disease events happening on the planet. And there's, thankfully there's very few of them happening in humans, but there are really devastating mass die-offs happening in the wild around the planet right now. It's been difficult for a chemist to get into conservation. Chemicals and environment are not usually favorably linked, right? So as a chemist, it was pretty difficult to figure out a way to get into conservation. I knew that I wanted to work in conservation, but as a chemist, it was really unclear how to plug in. Now, conservation biology has been around for 40 years, and it works beautifully, and it's very clear what needs to be done when a species is about to go extinct. A zoo would have an idea of how to intervene in that situation and what would be the founding population that is required to have genetic diversity. But these are biological tools. Where's the role of the chemist in this space? And then keeping in mind that that I came up through the pharmaceutical industry and I'm aware of this really robust pipeline for making advanced medicine today. I was shocked at the disconnect and how few chemists there are engaged in conservation. I saw this image, which I show in my talk, of a sea turtle just covered in tumors. I was shocked. I've worked in cancer for so long in the pharmaceutical industry. So to see a sea turtle just covered in tumors and to learn that there's really few options that this turtle has for, they will be treated in sea turtle rescue centers, for instance, but they'll just surgically remove the tumors. And I'm just aware of this, toolbox of cancer drugs that we have available to us today. It's like, well, look at this disconnect. What if we could bring modern precision oncology drugs to this situation? I thought would be, just a really ripe time to do this. It's getting somewhat straightforward to screen cancer cells against cancer drugs, and so it's just that it's a sea turtle, so their healthcare is maybe less well established than for humans. The cool thing is that cancer medicine drug discovery is a pretty well established field at this point. So we have good understandings of how we would look through cancer cells to tease out genetic mechanisms. And then we have the medicines that exist to interrogate those mechanisms that you can interrogate in the lab, right? With tissue cultures. We have microscopes. We have fancy instruments called mass spectrometers that allow this type of research. And this is all just very well established for human medicine. And so that really the mission is about taking those tools, which are so evolved for the invention of pharmaceuticals, and then approaching wildlife health challenges where conservation is an opportunity. I think that there's a lot of ethics that need to be discussed. Absolutely, the logistics of pulling this off are really quite challenging. The good news is that conservation biologists have been establishing these ethics and these logistics over the past 40 years. So, there's big questions. Wait, you're gonna treat wildlife with medicines? I don't know if I like that. I'm with you. I totally get it, right? But I'm also not okay just watching a sea turtle have a bunch of tumors be surgically removed and not receiving any of the modern healthcare that we would apply if it was a non-turtle patient. I'm also not okay with looking away from I talk about frogs and challenges that they're having with a fungal disease called Chytrid. It's just the biggest disease event that's happening on our planet right now. As someone who's invested in a career in making medicine for diseases, how can I look away from the biggest disease event happening in the planet? Of course, it's for frogs. So, well, what's their health insurance look like? I don't know. But one thing I can say is that when this fungal infection enters an ecosystem, the frog population drops and the incidence of human malaria in the region goes up because what's the ecosystem service that a frog plays? Well, they eat mosquitoes in the landscape, and so I think it's difficult to look at frogs as a as a patient that has health care, right? But I also think that we've maybe ignored some of the very important ecosystem services that every species plays on the landscape, and so we're really eager to plug in what we know about pharmaceutical health and modern medicine to these ecosystem challenges. We are getting really, really good at killing this frog fungus in the lab, and it's been fun to plug in all the modern tools of drug discovery. Like we're looking at frogs as our patient, but using really cutting edge pharmaceutical tactics, and so that has been incredibly rewarding work, and has actually been able to accelerate quite quickly. We are deeply invested in avian flu and using artificial intelligence to make drugs for some of the latest avian flu strains that are circulating both in the wild and in agricultural systems. So this was one that really caught my attention. That just it over the span of a couple weeks, all of the elephant seal pups in Argentina, or at least along most beaches in Argentina, died from avian flu, and this was one that got some attention, but we got very interested when we started seeing mass die-offs of bald eagles from avian flu, and so this was well before it became a problem in farms, and so chickens and then cows were also getting impacted, there were a couple cases in humans where it was a problem, but you know when it starts impacting egg prices, then it's going to get national attention. But we were just really shocked that there was these wildlife stories where mass die-offs were happening, and so that alone was enough to really spur our interest in avian flu research. And so we started learning from those in the field what strains of flu were causing that, and started developing drugs for them just in case something should happen. And then sure enough, things started to spill over into the agricultural system, and so we were already looking at this when the poultry industry was deeply impacted by avian flu, and so we hope that we can help that industry in this way. One area that I'm really excited about is work that we're doing with a tree. It's called the hemlock tree. It's the state tree of Pennsylvania, and we've identified individuals with collaborators that individual trees that seem to be resistant to an invasive insect that is otherwise completely destroying the hemlock forest here. And so we're trying to pull out some of the molecular signatures of that improved immunity that these trees seem to have, and then also looking at how we could make very selective insecticides to take out these invasive insects that are just having a devastating impact on parts of the northeastern American forest. There's sadly very few chemists who are engaged in this work, but the opportunity to make an impact, like the fruit is low hanging. And I feel like I'm after having worked in the pharmaceutical industry for over a decade, I feel like I am making some of the most impactful discoveries of my career right now, and seeing them being translated directly to conservation partners who are seeing the success in the field and be like, dude, like your idea, you like we saved animals because of they were all going to die, and like the formulation that you proposed worked. It worked well, and I've just never had that immediate impact in my career, and so it's been incredibly rewarding research. The tools of conservation work. We're taking this new molecular view where I want to be able to talk about the molecules that are involved in this systems, but the tools work. Conservation has brought back bald eagles. It's brought back giant pandas, and so many creatures have come back from the brink of extinction because of conservation principles. And we just have such robust science today showing that conservation works. Now, we also know that, ecosystem health is going to be tied to profits in the future, or I feel that very strongly that, it's difficult to maybe make that argument today, but it's just the truth. That like ecosystem health and profitability are intimately linked. And so while it's not yet clear what industry is the support behind this, I think it's abundantly clear that in the future, ecosystem health and GDP are going to be intimately linked. And so I think that somehow the economic argument will find its way over the coming years. And then scientifically, I think this research is so incredibly rewarding. Nobody's looked in these spaces before, right? No one has taken frog scrapings and put them on a mass spectrometer. There's just discovery that's happening everywhere because we're taking all the tools of chemistry and looking in these rather exotic environments and finding all kinds of fascinating things about biology. The things that we've learned about human cancer by studying sea turtle cancer are really inspiring, and I think that the opportunity for scientific discovery is we've just barely scratched the surface, and so we're eager to find more people engaged in this work and eager to find more partners to continue the mission. I would love to hear from people. Reach out via my website, cernaklab.com. Whether you're, an aspiring student interested in this space or a conservationist or otherwise interested in supporting this work, please reach out. We'd love to hear from you.
Thanks for listening to this quickie.
This episode was created by our superstar podcast team at TEDxLondon. Until next time,
stay curious.